to the robotics joint club meeting of the three clubs. This month, I'll be hosting on behalf of the RSSC. I'm Jim D'Annunzio, president of the RSSC Robotics Club, Robotics Society of Southern California, and we have the Riverside Robotics Society as well as Tech Room joining us, and also potentially Northern California Homebrew Robotics Club. Um, and so welcome. And today we're just going to have a business meeting and a show and tell. Maybe next time we'll have a speaker. We're trying to coordinate a speaker, and unfortunately I had all the mail back and forth went to spam. Somebody needs to improve the spam folder problem. So I missed these emails, and I thought they were on my email went into their spam, but it was the opposite. Anyway, so yeah, but we're working on getting a professor to talk, and I'll give more about that later. So first, I guess I'd like to see if I don't know if anyone is here, if Ben or Walter is here. I see. Wanted to find out if there's any update on the university, Cal State, on when in person, when we might be able to get use their facilities again. It's been a while. Oh, well, Alan might know a little bit too, since you work there, about the possibility of when the university might be opening up again to third-party groups.
Yeah, Walter, did you want to take that one, or you want me to?
Go ahead, Alan. I'm actually driving.
Oh, okay. Yeah, sorry about that. Yeah. So like most things that are happening with the pandemic in schools and stuff, a lot of it is happening. What is happening? Here's the pieces that I know. Is that they have opened up the campus to sporting events, which is a step towards normalcy. In the fall semester, the one coming up in July, August, we are welcoming students back at 50% capacity. So they're still doing hybrid instruction, but we'll have a lot more people on campus for the first time in a year. Yay. That's going to be great. And I'm sure everyone heard about the CDC rule change yesterday that if you are vaccinated or if you don't believe in viruses and vaccines, you can walk around outside without a mask now. So we're slowly going towards the, I guess like the lowest tiers or the highest tiers and back to normalcy. There has been no official announcement about allowing official clubs back on campus. That will most likely happen next in the near future. And then at some point we will allow events for, unofficial and off-campus type stuff again soon. So I actually work with the guy that schedules with the event. So we'll be among the first to know when they lighten up, but that's definitely the direction we're heading. And the other data point that I have is that we're planning on full 100% in-person instruction in spring 2021. So we don't have an exact date yet, like, oh,
2022, right?
Oh, I'm sorry, 2020. Oh, that's right. We skipped a year because of COVID. My bad. Or I skipped a year in my head. Good catch. So, we don't have any plans yet. I can't tell you in July, August, or September, but the infection rates are dropping lower and lower. More people are getting vaccinated, and it's our ability to open up is based on decisions made based on how people are dying. And I mean, not to be too crass about it, but a lot less people are dying than they were last year. Mm. So without giving you an exact answer, that's all the details that I have and the data that I have about how the campus will decide to let clubs go on campus. Thomas and I had a quick sidebar a few weeks ago. He was in touch with the library for the Riverside Club. and they were kind of in the same boat. The library is kind of open, but you can't sit down in front of a computer and there's no milling about. So we're still a little ways away from 2019 normal. Um, I'm hoping within the next 3 to 6 months, but yeah, so far so good, man. The world's making progress.
Great, yeah. And now as RSSC to the Cal State, are we considered an unofficial a club essentially that just uses their facilities?
Well, there's in the tiering of um, events that are allowed on campus. I kind of put them in three general tiers. Sporting events are first and foremost for a bunch of reasons. And they're the first ones allowed to come back on campus. Next, you have the official school clubs and school sponsored activities. And I haven't heard officially, but they're getting very close to letting them spool back up. And then after them, they will most likely allow us to come back. So, like,
Okay.
if you want to call it three tiers of letting clubs back on campus, we're tier number 3, and they're tier number 1 is back, and they are looking to open it up for tier number 2.
Okay, that's pretty. Thank you for that comprehensive breakdown of what we know.
Sorry,
Known,
yeah. Short answer, not yet.
known knowns and known unknowns. So that's good. Yeah, I mean, we just wanted an update. Any information is better than none.
Jim and Alan, once we get back to the in-person meetings, one of the nicest things about these Zoom meetings is that we've been able to participate as 3 clubs brought together, or sub-clubs. And once the in-person things start again, it's unlikely that some of us may be able to attend all 3. So we'll just attend the one that we that we usually go to. Is there any possible plan for doing maybe these meetings online again during our, alternate maybe every other week or something?
We haven't got to that point of talking about that yet, but what we had started already is simulcasting our in-person meeting on the internet. So and we plan to, I mean, as far as I know, we're planning to continue that for sure. So that'll be broadcast, and then you could even take questions and things like that. We could we'll have to talk about that in a business offline, but we definitely could consider doing a Zoom thing as well. But we'll have to. But if the whole thing is broadcast, then anyone can watch it live or afterwards, same as this, and whether we can get participation from people that are remote, that through the YouTube thing, I think, yeah, you can, but we'll have to test it and see how well that works. So yeah, thank you for bringing that. But but we're looking forward to getting back to in person, and hopefully we'll have a medium between keeping what we have to the remote viewers and participants as well, and then be able to do it in person. So yeah, we'll update as time goes on.
Yeah, if recordings are available from each of the meetings somehow, that would certainly mitigate the potential problem of not being able to share what's going on with some of the other groups. So that would be nice.
Yeah, now I only speak for the RSSC. We started broadcasting and recording on YouTube back in 2019, and we could certainly share with the other clubs anything we know about how to do that. But it's just YouTube broadcasting and recording, and yeah, that would be that would be cool if Riverside could do it as well, and Tech Room if they want.
Yeah, and on the Riverside side, we were toying with it before everything happened. The RSSC side definitely was way ahead of the game for the live YouTube channels and the recordings, which really helped out when we had to switch models to online only. The only thing keeping us from doing it reliably on the Riverside side was crappy internet connection at the library. So worst case scenario, we pre-record and publish afterwards. But then if something changes, then at the bare minimum, we should be able to live broadcast um, the meeting for anyone who's not able to attend in person as well. I think it's a great idea.
Yeah,
And Alan, with the live broadcasting, would you still record them then?
Oh yeah, for sure.
yeah, we record. We did this already at RSSC meetings in Long Beach, and so it's just a matter of getting it going again, and then if Riverside can do the same, that's up. That's the separate club, but it's definitely possible, and we look forward to that. We look forward to being able to, because a lot of us can't make it to all these meetings, and yeah, so that would be nice, and we might want to make it to. It's just too far.
Yeah, Jim, there's a lot of meetings now between the three clubs here and the one up in the San Francisco Bay Area. That's a lot of meetings.
Yeah, it's too many. I mean, I was starting to have turned down meetings. I'm like, no, I can't go to all these meetings. Yeah, I mean, yeah, I didn't go. The homebrew robotics ones can be very good, but I didn't even attend that many last year, mainly because I didn't get reminders, and that you have to have the time and everything. But they do record theirs as well, and but there is a delay between when they record the meeting and when it gets posted. Could be months actually. So, and that's up to every club to when they get the recording posted, and we'll try to do that as much as we can, and then rotate the responsibility if we should probably do that, so that one person doesn't have to do it forever. I guess that comes under the secretary, potentially the secretary officer, or any of the other officers that are decided that are volunteer. But we'll make sure to, at least on our part, and please, if you see a missing video, email the group, or I emailed the homebrew robotics as well. I mean, it's like, do you have that one where the guy from Roomba was, gave a talk and I missed it. And yeah, they didn't have that one up, but anyway. So, and I just wanted to mention, yeah, the call for speakers again. This, I'm only hosting this month, but oh yes, and please post any of your any show and tell you want to do in the chat window, and we'll get you in.
Jim, if you would remind me after the meeting or sometime this weekend, I'll see if we can schedule in one of the guys from JPL. We got two people said yes at JPL. They will be glad. They'll be glad to give a lecture at our online meeting.
Oh, that's great. Yeah, we certainly love JPL talks, and yeah, I mean, again, since we're on a rotating basis of clubs, we all have to just sort of, next month is Riverside, as Thomas is your month, and then after that is the Tech Room again. So hopefully we're all flexible, and whoever gets the speaker at whatever date, we can fit them in, because the speakers' schedules are more pressed than ours, and we so yeah, that's great. So we should try to schedule those JPL guys, and yeah, if anybody has any other suggestions, please email me or the RSSC or any of the officers or presidents of the clubs with suggestions of speakers. Again, yeah, I'm working on one right now, and we'll try to get her to come. And I'm still, yeah, negotiating. Sometimes there's a form you have to fill out. In fact, for these university professors, and it's like says, is there an honorarium, which is a fee. I never had filled one of those out, and as a nonprofit, we probably won't be able to. We won't offer honorariums, but it's some organizations do that. But just so you know, yeah, our budget doesn't really include, at least not to my knowledge, we include kind of speaker fees or something like that. This is all volunteer. And if anyone else have any business related items to mention,
I have something.
go ahead.
Yeah, I was talking to the librarian today, yesterday actually, and about when she was opening and stuff like that, and still no further plans of when we'll be bringing the Riverside meeting in person. She says it's all dependent upon the county. But she asked us if we want to do a robot expo, probably not this year, but next year. And I said I would talk to the officers of the other club and everybody else and see who would be wanting to do an expo. And she says she wants to bring in this group called the Friends of the Library and get a grant for it. And this way, there's a whole lot less heavy lifting. And when I say heavy lifting, I mean very heavy lifting. At the last expo, we were carting these 300-400 pound tables around. So let's bring that up, not today, but another meeting. Let's chat about that then. Okay, Jim?
Yeah, absolutely. All right, yeah, so we'll switch over to show and tell, and unless anyone, well, is there anyone else before we do that? Anything else? Anybody else have any business related? If not, we'll go right into show and tell, and looks like Thomas, you have one, and then Alan has one to talk about Teensy Spot, and I have something I'll do whenever it's not whenever everyone else is done, or I can fit it in. So all right, I guess we're ready to start.
I've got two things to show, but one's not quite ready yet. So I want to split my time and I'm going to show you A, and then somebody goes, and sometime later I'll show you B. How's that sound?
That's great. We're flexible.
All right, let me share my screen here. So can you see the screen?
Yeah, it's a little it's a low res kind of, well, at least on mine.
Well, let me shrink it down and see if
Can't read the writing.
It looks unfocused.
Oh, there. Is
that better?
It's resolving. Oh, it must be a connection issue.
I'm trying to minimize it. Let me shut down
That's barely readable, but no.
I'm going to shut down a web browser of mine since
That,
it might be taking some of the bandwidth.
it's
Okay.
getting better. That's clear now.
Yeah, much better, Thomas.
Okay, so great, thanks. This is, again, the Easy Robot, otherwise known as ARC software. And recently, I've been playing more around with the voice and getting the voice to change pitch, to change emphasis. I gave a show and tell many months ago that showed some of this, and I'm going to revisit some of those things and with some updates. First thing I wanted to show is it's really cool that you can have it change voices midstream, and this is really interesting. So let me know if you cannot hear this. So here we go.
Zira is here.
Mark is here.
Eva is here.
David is here. Lawrence is here.
Amy is here.
Hi Amy, how are you?
Not bad. What about you, Lawrence?
I'm doing fine. Thank you for asking.
Good to hear.
Well, I've got to be off.
Bye-bye.
Goodbye.
You hear that okay?
Yeah, pretty good.
That was cool, huh? All those voices, they switch out dynamically, which is really an interesting thing. I'm trying to get my robot to sound more and more human-like. So I've been integrating some of these called vocal prosody. And prosody is the way words are speaking, the spaces between words, the emphasis and the volume, and other things as well.
1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4.
So there we were changing the rate of the speaking voice. Next, we're going to try the pitch.
When I'm tired, my voice gets very deep and I speak slowly. This is my normal voice. This is my high voice. This is my low voice. This is my normal voice.
Here's one with emphasis.
I want to kill all humans. I want to kill all humans. I want to kill all humans. I want to kill all humans.
Kind of creepy, right? So that's putting in different emphasis. And you can see it's got a long way to go. This is nowhere near what a human actually sounds like. I found out that you can get a lot of emphasis and just by changing the volume. So here's one changing the volume.
This is the regular volume. This is louder. This is softer. This is normal.
And each of these is obviously programmed in. You can change it dynamically. Also, by pausing, you can add emphasis as well. Maybe that script's not working too well. Okay, we're going to skip that one. I showed this last time. We play with phonemes. We can change bits and pieces of the sound. Well, let me look at that one just a second. Can you see the screen in front of the screen?
Yeah.
Let's see if I can do this without, no, I don't think this will work, but we'll try.
Thomas, is this still the nightmare AIML syntax?
No, this is, oh God, what's the name of it? I forget the name of it. When I remember the name of it, I'll tell you. This is a special syntax for speech synthesis. That's not going to run today. We're going to go to the next one. So the last one I wanted to try, I wanted my robot to, I don't know, did we try this one?
How are you today?
Yeah, that didn't work so good. But I wanted my robot to at times sound angry. So I tried 100 different ways to get the robot to sound angry. And this is what I came up with.
Thomas, I hate you. Thomas, I hate you.
So we're kind of emphasizing the word hate. There's a whole lot of things you can do, but this is just a simple putting in a break. A break means a pause, and then changing the emphasis. And that's how I got it. If you want to hear it without the other stuff on, we could. Here's what it sounds like plain. Let me comment this out.
Thomas, I hate you.
It's just not as effective, you know?
Thomas, I hate you.
And then we have this one. And we have the other one where I put the emphasis in and such.
So, Thomas, can you emphasize? Sorry, can you emphasize different words within that sentence, or is it just one word?
Any word you can emphasize, and you can put breaks in to increase the emphasis. You know, what is emphasis? Emphasis is could be volume or a pause. And usually volume and pause, occasionally pitch. How are you? How are you? That kind of thing. And you can do any of that with this, although it doesn't sound very natural.
So I think her statement of anger toward you, you should emphasize your name and emphasize hate, and it would sound more natural. Both of those words. Thomas, I hate you.
I'll try that later. But that's my demo. That's my demo for now. Who's up next?
Actually, Thomas, we love you.
Thank you.
Well, we can. Thank you. That seems, yeah, that's pretty cool. And we'll do the. We'll see your second half after. And now we could, yeah. If you, I have a speech thing too. So, but we can. We'll go back and forth. It doesn't really matter. So Alan has a teensy spot to talk about. That sounds interesting.
Oh, do I have a rabbit hole to share with all of you? Oh my goodness.
Teensies, huh?
All right. So, and I think I briefly touched on it last time we met. And now that Sergey is here in person, I can tell him to his face, I blame you for the ESP tiny rabbit hole that I've fallen down. So I picked up a couple of these. You can get them with a carrier board for like $5 and change on AliExpress if you're patient. There was a pan tilt doohickey that I think I showed last time, and that evolved into a design called Turret, which was just a way for me to experiment with pan tilt mechanisms. And every pan tilt mechanism needs a laser pointer. So I bought 10 3 milliwatt 3.3 volt laser pointers, guts from Amazon, and then the camera. And then the whole point was to practice with face detection and then, you know, aiming strategies. And shortly after I did that, I found out that there are servos that are smaller than the MG90. So the Turret and the Todd, they're all using MG90s. They're super cheap as $2.50 each, Metal Gear, and they're super fun. And then I found out that for twice as much, you can get find ones called K989-58s, which have about the same width and depth, but are significantly shorter than the MG90s. And so I've ordered 14 of these for another project. And the Rolls Royce of tiny micro servos are these little guys, the PDI D56 MGs. These are coreless. And so I imagine they're even better quality wise, and they're even skinnier than both of the other two servos. They're just a little bit taller than the 989s. So I ordered 4 of these guys, and I ordered 14 of these guys, slow boat. So hopefully those come in over the next couple of weeks, and I'll get them on my workbench to play with them. So with new smaller servos in mind, I decided to revisit an earlier project that I never got around to, which was making the smallest possible spot that I could using servos, and now using an ESP32 base brain, or this week it's a TNC 4.1. So I'm this is the current rough draft proof of concept for a spot-like device. When it's standing, it's about 80 millimeters from the top of its battery to the floor. I printed out a like a proof of concept. I decided to iterate often so I could get like kind of a hand feel for how it looks like in real life. And there it is with Turret right there. And so far, it looks like everything is going to work. I've got enough room, well, almost room for the battery. The Teensy 4.1 goes underneath. Servo placement's good. I've got some cool shoulder joints, and I found a pretty neat way of doing a kind of supported elbow joint. I haven't really figured out the wire routing yet, but yeah, so far everything seems like it's going to fit. So I've amassed a desktop of teensy type, small type things that started with the ESP32 AI Thinker Cam. The Teensy 4.0 and 4.1 are powerhouses. The 4.1 is the one that's going to go as the brain for the teensy spot. And the only thing that's bugging me, and it shouldn't, but it does, is these Teensy 4.1s are super powerful. And you have lots of I/O, oodles of I/O pins. They're perfect for this application. The only thing that it doesn't do is Wi-Fi and Bluetooth. So it turns out no matter what I do, all roads point towards using a second board with an ESP32 on it to facilitate the Wi-Fi and Bluetooth communication. That's the only part that I'm not super excited about. And even if you go not ESP32, any Wi-Fi board that you purchase is going to have an integrated 32-bit microcontroller, which seems like a little bit of a waste, but maybe there's a way of leveraging it to use some brunt on here and the brunt on the TC 4.0, and then like micro ROS to carry everything over to a laptop or an Android. So I'm going to print out this version this weekend. It has more stylized feet. It's pretty close to everything being able to fit. And then as soon as the servos come in, I'll take final measurements of the servos and then build one and wire everything up to like a PCA 9685 I2C 16 channel PWM driver, just to see the thing stand up and walk. And that's my rabbit hole.
Wow. Is this a fresh design for of your spot here?
Yeah, it's, it's evocative of the Boston Dynamics spot, but I had a choice between maintaining spot proportions and just keeping spot features, and I opted to make it as small as I could while still providing some spot features. So he's a little bit squat compared to the spot design. But it's got kind of a kawaii, cute feel to it. The whole thing fits in the palm of your hand. And I think I'm going to try to build it.
And that has a camera, right?
Yeah. Right now I'm planning on using the OB 2640, I think, or 6240. A cheap 2 megapixel camera. Depending on what mood I'm in one version of the solution, I just slap one of those AI Thinker ESP32 boards up front and keep the camera attached to that, because that's super simple and easy to do. And then in another version, hey, you're wondering how deep the rabbit hole is. I made a posting about JLC PCB and rapid PCB turnaround and their automated SMT assembly stuff. They've got some really compelling pricing for auto assembling minimum 5 boards with any SMT component that they have in stock. So part of the game is to design a board around components that they have in stock. Like if I wanted to put in an MCU, let's say 6500, if they've 6050 maybe, something like that. And then if they have it in stock, you can add it into your board design, and then they just charge you the cost. So I have done some work in KiCad, and this time I decided to try out their Easy EDA. It's an online circuit placement and schematic design tool, very similar to KiCad in terms of functionality. So here I'm working on a really rough draft of a Teensy 4.1 carrier board with 12 voltage dividers and filtering caps to knock down the 5-volt potentiometer position out to something that a 3.3 volt device can manage. It's got this fun little 3D viewer, just like KiCad, that you can use. And it's pretty well integrated. Is that after you get your design done, it'll do rules check, and then you can generate your, let's see, TNC spot brain. Then you can generate your Gerbers and your placement files, and then upload them over to JLC PCB for a turnaround. For both of these boards that I've been toying with, and they're nowhere near finished. I'm awful at this, but I have been watching a lot of YouTube clips on circuit design just to make sure I don't do anything obviously stupid. It's turning out to be, I don't know, $25 for 5 boards. So you invite a couple of friends to your project, and but really $25 for a a board about this size, and with SMT placement that they're going to do for you. That for me is kind of amazing. That means I can design boards with finer features that I can hand solder. So I'm hoping to have this ready in a couple of weeks. I'll probably just jerry rig something to get the servos on it when the servos connected when they arrive in a couple of weeks. But this is the other part of the rabbit hole. Is I think I'm going to design another board as a carrier board, and then depending on how kitchen sinky I feel, maybe integrate the IMU and max audio amplifier chip, 12 channel ADC, and run a wire from each servo over to inaccurately measure the position of the servo, buck down converter down to 5.5 volts. And I'm trying to do look into drones to understand how they handle lipos, because drones are so light. I'm assuming that they don't carry a full battery management system on the drone. I think they're relying on the charger. What I think they have, and I'm welcome to be proven wrong, because it's not a lot of people, I haven't looked through any designs to confirm this yet, is that I think they're just using a low voltage cutout, where with a 2S, if they make an assumption that if your voltage drops below 6.5 volts or 6 volts or whatever that cutoff is, it just disconnects the LiPo, and then all the BMS is in the charger. I think that's what they're doing to save weight, and I'm going to try to do that on this board as well. Just do a low voltage cutout to protect the LiPos, and with the assumption being that they'll discharge rather evenly, and then the charger will catch any weirdness if one of the cells goes bad.
Alan, I have a quick question. Could you go back to the slide that showed the ESP32 little board?
Oh yeah.
Okay. Where that not that one. No, where you had it first.
This one?
No, the one that you had first. That one right there.
Okay.
Where the antenna is, the onboard and external. It says if you need to use the external antenna at position 2 in that blue sentence above, please do it yourself welding by yourself. So I obtained one of these boards where this connector, the circular connector, was missing. Is it possible to connect an antenna to the 2 terminals where that connector normally would have gone?
So there are.
And how do you? I mean, it says do the welding. So what is it that you use actually to bond a wire to that area?
Well, it's a great question. I'll try to answer it with a combination of what I've seen so far and what's available. So there are literally 100 plus different formats of the ESP32 system on a module, and in some variants you'll have a smaller board where it is. Let me just move back over here. Where oh, that's the backside. Where it's only an external coax antenna, and then there's no built-in antenna. There's some where there's only a built-in antenna, and the pads might be available for the coax connector, and sometimes they're not. Well, and everything in between. So if you're asking me if you can take an ESP32 board where it has the coax pads but not the coax on it, and if you're able to add that on afterwards, I'm honestly not sure if there's any additional supporting circuitry underneath the shield.
Well, the thing is, it appears that just that connector, the little circular connector that connects to your antenna, was missing from this particular board that I got. And these connectors are available, but the thing is, there's two little pads right next to, from that diagram that you just showed. Not this, but the one right there. Up in the upper, where the antenna is, in that upper right-hand corner, right next to where your pointer is, or your hand was, there is a contact, and then just to the right of that, there is the contact where that connector actually was supposed to be welded on or whatever. So I guess what I'm trying to find out is if there's a way to bond a wire with some kind of adhesive or something to those two places where the connector would normally go in order to connect an artificial antenna of some sort, or an artificial connection to an antenna.
I can help here. A lot of these guys say weld when they mean solder.
Okay.
Yeah, weld means solder, and that's the Chinese, you know.
Yeah.
That's what I thought we were talking about, is solder.
Okay, well that might actually, I could try that and see if solder would hold to those two
One
terminals.
thing I'll caution you is they're not using lead solder for most of these now. So you have to be sure that your soldering iron is set up for, that you use a clean soldering iron and the plastic kind of solder they have these days.
Well, what kind of, Les, what kind of solder is that? That's a plastic type.
It's when you go into the shop, you look for the one that's got the new recycle seal on it.
Oh, okay.
Because in 2007, I think, a lot of the places went to the non-tin solders. They didn't want lead and tin.
Yeah, because all I've got is just the thin lead and or tin, you know, type electronic stuff that you'd use for metal terminals.
Yeah, and if you contaminate them, they won't stick good together.
Oh, interesting.
So you're talking about soldering your own UFL connector surface mount on a $10 board, yeah.
I wouldn't do that.
You have better skills than me. Yeah, I've tried this. Like,
let me jump in for a moment. I am not an expert on ESP32. I used it in a couple of projects, but what I read and what I see on my boards is that you cannot use internal antenna, that little zigzag thingy next to the ESP32 chip, together with the antenna, external antenna that is connected through this little connector. Now, what you have to do is to look at that little switch area next to the round connector, EFL connector, and make sure that the 0 ohm resistor, which is soldered there, you can see it here, it is soldered in the right direction. It has to be soldered either in the direction of the zigzag antenna or in the direction of the external antenna connector. Now, if you don't have the external antenna connector, I don't see any reason not to solder just the cable. You know, I mean, clear the cable, you know, 1 centimeter of cable, and solder ground to the shield of cable, and the other end to the central point or to that 0 ohm resistor location. And honestly, I don't feel that the normal 40-60 solder will not do the job. I don't see any reason. Just use the right flux and try it. That's it.
Yeah, no, yeah, thanks, Sergey. And Buzz, the last thing, like just for a sense of scale, and I have the same challenge all the time working on small projects where I can zoom in and enhance to get a better look. Let me turn off the sharing for a second. The surface mount component we're talking about soldering doesn't even resolve in the camera, so I can barely even see it. I'm not even sure how to manipulate it. I'm not sure if I have a soldering iron with a fine enough tip to even get at it.
What are you talking about? Shifting the antenna from internal to external?
Yeah. So you've got
The
that
little resistor. You got to
Yeah.
move to one point or the other.
Yeah, so it's hard to even see here in person. To be honest, given a choice, I would probably, if it doesn't have the coax on it, and you're thinking you can jerry rig like a coax antenna, I would probably just spend the $4 and get the ESP32 with the coax antenna on it. But then you still got to figure out how to solder that little tiny.
I have with my iron, I can barely do it, but yeah, I mean, mine came with the antenna. I have the antenna.
Yeah, is that an 0402 or?
I've got two of these things.
Yeah.
Well, this is not a needed component. This is a zero ohm resistor.
I got a board here that
you can just destroy the resistor, take it with the solder, thin solder, iron, and then put a solder blob on the right connection. I mean, it's very easy to do, honestly. Just try it.
I've done just that. That's exactly right.
Yeah, the board that I have does not have the onboard antenna. It is just made for the external antenna, and unfortunately the little connector was missing off of that particular board. So, I don't know, I could makeshift something to just connect a wire to where those contacts are for that connector, and give it a try anyway.
I got a board with mine that makes sure that I can hook up to the USB port directly without having to have that little converter thing on it. What I have here, two boards.
Yeah.
I don't know if you can see that or not.
Yep, that's it. The AI thinker with the motherboard.
Yeah, and also I have one little just by itself. Actually, it's on this breadboard. I haven't done anything with it yet, but it's the same thing.
Yeah.
I haven't really done much with it yet. I've been trying to shift my gears to something else at the moment. I probably need to sit down and jump one of those things. So I use the external antenna and get the serial port to be recognized by my computer. Once I can do that, I can probably simply program and get it on the internet really quick. Good example of how to do that. Huh?
Yeah, I may just use that board just for other processing without bothering with the Wi-Fi and Bluetooth. Just use it for other kinds of applications on board, something. So.
Well, I mean, it's got an app that sets up a thing on the internet where you can jump to the address and you got controls that adjust it and can't do things with it. You can actually do really simple face recognition stuff like that with it. Just the way it's like that, Buzz.
Okay, well, good ideas, guys. Thank you very much for addressing this delicate issue of delicate handling anyway.
Well, I mean, I'll let you know that, I mean, it's a very small resistor. I think I could probably get it off with a tweezer and stuff.
This board doesn't have that resistor. There is no resistor because there's not an internal antenna on the board. it's just connected directly somehow to that chip.
Well, according to what they say in the instructions, if you got that little part thing on there and it wasn't jumped there to begin with, I have to take that resistor, move it, and put it in the other thing to make it jump to the external antenna. Right now, it's using the antenna built into the board. The external antenna does give you quite a bit of range.
It's not a really super issue for me. It's just I was curious if there was a way to, fasten a wire. Cable.
Well, theoretically, you could, as Sergey was saying, you could probably take that resistor off and then put a little jumper wire in there and jump it and do the same thing. The resistor is very low anyway; it's almost a dead short anyway.
There is no resistor. The only choice is the external antenna, but the connector is missing. Period.
Oh well, I mean, both boards I have the connector on it, so.
Yeah.
And then according to that thing, I have to
Actually,
move that little.
I do have a second board that does have the connector, so if I want to use that for Wi-Fi, I can always connect an external antenna.
Well, I mean, you can use it for short range for, you just want to be able to go for the range on the antenna is quite extensive. It can almost go line of sight with it, so.
Yeah. Well, anyway, don't want to belabor this thing, but thanks, guys, for all the suggestions and info.
Well, I'll let you guys know if I get both of mine up and running at some point. If you're interested, I'll keep you guys informed.
A couple of fine points about ESP32. First of all, you very quickly run out of the pin points, pin legs, on this series, because there are like half of what you normally have with Arduino. So be careful with the legs that have crystal connections. There are like 2 of them which don't allow either input or output. They are finicky, to configure. The others are fine. You can use them as usual I/O pins. The second thing is that it does have 2 cores, the ESP32. And one core is completely running RTOS, which is running Wi-Fi. And the other core is, for you to use with Arduino sketches. The interesting part is that you can use full functionality of RTOS, scheduling, and semaphores, and whatever you want from your Arduino sketch. So it's a huge kind of feature for ESP32 if you need real-time OS there. So just keep that in mind. A nice platform.
Sergey, thank you for that information. That's really helpful to know. Thank you very much.
I'm here to help, guys, or to bother you with the cucumbers grown in Alabama when they do grow.
Oh, I always like all your help, Sergey. So that's cool. Like that.
Yeah. All right, and so I guess Alan, thank you. Were you finished? I wasn't sure. You were that was a question. You're muted.
Yeah, and actually I went over. Sorry about that. But yeah, that's all I've gotten. It looks like in chat, Thomas is ready for his part 2.
Yes. Yeah, go ahead, Thomas. If you're ready.
Hi. How's that? Can you hear me now?
Yeah.
Okay. Can you hear me, Tim?
Yeah, I can hear you, Thomas.
Good.
It's an interesting background. I don't like the green behind your ear, though.
Well, here's my screen. Can you see my screen?
Yep.
You see this window here?
Yeah.
All right. So this here's a story about a man named, this here's a story about a robot.
Okay, what is that?
So we're working on all sorts of ideas for the next phase of Simone, the humanoid robot's arms. And I purchased a set of these. These are mannequin arms with posable fingers. And
how much do those cost?
I don't remember, maybe $50 for the pair. Those are life size.
Okay.
And of course, well enough is never well enough for me. I figured I was just gonna put some strings along the fingers and try to open and close them like you would do an in-move robot by just contracting and expanding the strings and such. But I didn't do that. A few days later, I got one of these. This is an Actibotics claw. And I said, I have this and I have this. And this doesn't move, but this moves. but this doesn't move. So I ordered it and it came like that. And after searching around online for a while, I found an assembly video and then I finally got it to look like that. But I wanted to marry that with that. So I cut off a piece of it and I wound up with this.
Well, that gives you the thumb and index finger gripping.
And the good thing about this is I can pick up a cup.
Basically a claw.
I can pick up well, you'll see a beer can, a soda can, a water bottle. It's got a pretty good torque because I put a good strong motor on the back of that. And so
Well, that gets you a basic claw function with finger-like things.
claw, yes. And because
it's not 5 fingers and a thumb.
Because this is supposed to be a humanoid robot, and I want to put silicone rubber around it, I said, well, let me put this thumb and finger into a glove. Well, I don't have just gloves at my house. I have gloves. Gloves based on a human hand made out of silicone rubber. So I jammed it.
That's almost the Thing.
I know, it could make some great horror movies.
The Thing from...
Well, what you need to do, Thomas, is put a shell around where the motor is at and stuff to give it more of a form that can go over it and not be jammed like it's being jammed right now.
And so with the glove fully on, I trimmed the glove. The glove actually went up to the elbow, so I had to trim it a bit. And that's what I wound up with.
Now, you bought those wooden arms from a company. Do you have can you provide a link to who you bought them from?
Yeah, I can do that before the meeting's over. So
Okay.
this
Well, I mean,
really good.
that's
And-
basically the same idea of very basic artificial limbs when they first came out with stuff. And now the components are a little more readily to get out at there. But again, you can I can see the servo underneath the skin moving. You need to put some sort of shell around it to give it more of a form.
This I put together yesterday, Tim. So this
Oh, no,
is,
I'm not saying what you did is wrong, bad, or indifferent, Thomas.
but you can see that it can easily grab a bottle, a can, a cup. And then I wanted to see if it could hold a screwdriver. Well, the rubber really helps with it holding things. And yes, the servo is way too big for the hand. And I have to find a smaller servo and remount it. But I just thought this was a very workable solution.
For a small part of it, yes. You need to get the other fingers in there, even though they might not be moved, they still will make it look more alive.
Yes. I figure I'll just drag the rest of the fingers along with the pointer. Because most of us, when we close our hand, only drag the remaining 3 fingers along. We don't use them too much unless, sometimes I put a pinky under a drink to keep it from slipping through, but that's about it.
Now, hey,
Well, I
Thomas,
like what you did so far, Thomas. It's a good start.
yeah, cool. Yeah, it's cool, Thomas. Do you have to, like we talked about in a previous meeting about the torque on the motor when you grasp, say, a bottle, a glass bottle that's thick versus a small thing like a screwdriver, you have to know what you're going to grab ahead of time so you don't burn out the motor, right?
That's right.
Well, I mean, there are ways of sensing the current draw on the motor so you don't overdrive it. But again, your hand's capable of holding different positions. And these 2 fingers are for a lot of the gripping functions, but the other fingers are used for tool work. For example, when you grab something like this. I mean, you can grab it with 3 fingers like that.
Yeah, that was the other thought. Maybe I would extend another piece of it into the middle finger, and then I would have a 3-fingered claw that would actually be powered.
Well, what you could do, Thomas, you could get another claw mechanism there and make the other 3 fingers move with it.
I could. So I have another servo that's a lot more tiny than this, and I just haven't had the time to swap out the servos, and I'd have to build a new piece to hold everything because the other servo is about 1/3 of the width of this one, and it wouldn't fit into the piece of plastic they sent me with it. And besides, I don't want to use that; it's too wide. But this was an experiment and it worked, and I am very happy with the results.
Pretty cool for a human, turning a robot claw into a human, you know, start of a human hand.
Well, that's basically the same ideas that they done with the early Meyer Electric prosthetics. They basically just only had these two fingers doing anything. The other ones they were just cosmetically, and that's all it did is did this. And you can do a lot of stuff like that. The thing is, to grab anything, 3 fingers are required. The other 2 are just that, or maybe hold it a little bit better. But again,
Yeah.
you know, it's Thomas did a cool thing there. I like what he did.
Yeah, for
Always
hobbyists.
room for improvement.
Yeah, if we're just hobbyists, so any, you know, this is the first time we've seen it, at least in my memory on.
Well, I mean, it's basically you have to consider my background of working for animatronic companies. It's the same idea. He's just doing those 2 fingers. I mean, you can do a whole 5 fingers and a thumb pretty easily and mechanically. It's all based similar to what he's doing here, but every company does it slightly different.
Yeah, I'm sure
And
it's
how
a
the
lot
skin
of
is
work.
wrapped, how the skin is put in there is one thing. For example, I mean, you can have a nylon under the skin. The other thing slides over or fills out the area a little bit more. I don't know where Thomas got these silicone gloves from. It's pretty cool looking. I like it. That's why I asked where you got those forms from. I'll buy a pair for myself.
I'll get that for you.
I'm working on my own version of.
Yeah, Thomas,
Simone.
why don't you post if you have the info on the what did you call it? The silicone. Well, there's 2 things here.
Gloves.
What?
It's a silicone human glove, basically.
So Thomas, one other thing to consider, although this is very preliminary and you've done a great job on this, Linda points out that it doesn't look very feminine as a hand for Simone.
Oh, no, that glove is very masculine, and it will not be used on Simone. It will be probably used on one of my other robots.
Oh, that's great.
But you had this one available, so you used it for your test.
That's right.
Which is cool.
Yeah, to make one for Simone, there's nothing out there I saw, so I'm going to have to cast.
Well, there are, Thomas. You're just not looking in the right places. There are ones you can get that are female.
Send me the link.
Yeah,
you're not looking in the right directions, because this is the whole thing that does some things that most people don't know about, that the whole community out there does other things with this.
I know that's why I liked your meeting the other day, because I want to learn that aspect of it.
Yeah.
All right, I'm done. So who's
All right.
next?
Thank you, Thomas. That's some nice development there, prototyping.
Oh yeah, it looks really great.
I mean, I haven't done anything with claws, and I'd like to at some point claw arm type additions to the robot. At least even a rolling roving robot, wheeled based, could use an arm of sorts, or a claw. In this case, a claw would be completely appropriate.
One thing about the rubber there is it gives it a good sticky grip, so it can hold things, and stuff doesn't slip from his hands. You sort of pick up the screwdriver.
Yeah, definitely.
Yeah, you can, and there's things you could do with the servo. You sense the current to give you some idea how much force you're grabbing it with. Also, you can put on the fingertips. You can put what do they call it? I forget what they call the darn things.
Force sensor.
A force sensor, yeah, but there's a term for it. I don't remember what they call it. Anyway, you do that on the inside the fingers on the inside.
one is strong with the force.
Hey, that works.
Tactile sensor. Someone wrote tactile sensor.
No, it's just, oh, I remember now. It's a, you would put like a strain gauge in there.
Yeah, so that it's an important thing we mentioned, that was mentioned here before, was you either have to have a current sensor, and I don't know how you hook that. I mean, to some of these servos, unless they're, if they're just a cheaper servos, then it may be kind of difficult, right? You have to be
Well,
able to sense.
there are servo driver boards that have the capability of sensing the currents, of being able to sense the current on the power going to the motor to get some idea of how much force you're applying.
Yeah, so it's
I forget who
Alan,
does
did
that.
Gray sense the power usage?
That's not the approach I went with, but I actually did a very interesting experiment that you might be able to take advantage of. If I can share my screen really quick, I'll
go for it, Alan.
I'll show you. Let me see a video clip.
Okay. Oh, there it is. Cool. Uh-oh, searching through there.
And this was from a couple of years ago. And it was a little experiment to see if I could integrate force feedback using FSRs. And I'll post the link on the chat in case anyone wants to see it.
Fricassee shift, right?
But basically what I did was I gave the servo room to slide a little bit, and I put an FSR on the side such that when it applied force, it could sense it, and it would reduce the position of the finger to maintain a maximum or a minimum force as experienced on the FSR.
Where's the sensor? I don't
What's
see
an
it.
FSR?
Force sensitive resistor, it says. Right?
Force sensitive. It's a force sensitive resistor is what it is.
Oh, cool. Yeah, that's
what Thomas needs.
I don't see this. I don't see the sensor there, Alan. Where did you put it?
Oh, so it's actually here. Let me back over here.
It's got to be on the finger there somewhere.
Yeah, let me see if I can get a part where I'm not blocking the view. So the servo is mounted so that it can slide back and forth a little bit, just a little bit, right?
Okay, so I got a little give in the servo holder.
Yep. So as the finger closes, it exerts a lateral force between the servo and the frame on this side. So I just took a little FSR there with a little bit of Arduino code that says, hey, if the force that you experience is over some value, loosen up the finger a little bit. And the demonstration you're seeing here is actually what's called active compliance. So
I like that. I like that.
That's very important.
You have a spring inside of it to bring it back to a normal position.
Oh, I see what it's doing. Yeah,
that's just the motor doing that, right?
Is it the sensor underneath that white plastic area there somewhere? I see a connector right in there.
Yeah, exactly. When you're talking about, I'm kind of mixing up compliance with force feedback. But when on the compliance side, there's two general ways of making something have some give, right? So that it's not a solid piece of whatever when it's moving.
Right. So basically, it really doesn't come and crush something. It got a little bit of give there.
Yeah. And in a passive compliance type solution, you just basically have a spring in line. So there's a spring and a spring constant, and ignoring accurate positional control and stuff for a moment, the spring introduces some compliance so that it has a little give when it moves. This is the other way of doing it called active compliance, where based on the force applied, I will using code alter the command position and therefore the force that's being exerted against the finger to maintain some minimum or maximum force throughout the range of motion.
So basically, the force sensitive resistor is sensing the movement of the servo a little bit.
Yeah.
So that's interesting. That worked quite well.
I like that. Do you still have that?
Oh, it's probably sitting around in my workshop somewhere.
So, Alan, what is the actual physical shape then of that force sensor resistor? Is it kind of a flat thing with a couple wires out each end, or what?
Yeah, let me see if I can find a
picture of it.
pick. So
Some of them are circular like that.
Oh yeah, the circular.
Oh, okay, got it. Interesting.
You can get some that are linear, but most of them are circular like that.
Yeah, the way they work out is they're
He's
basically
using the resistor to, since he's got the servo a little bit loose, he's using the resistor to keep some sort of track of the looseness, and that helps with the compliant part of the finger.
That's very clever. That's really cool.
Yeah.
It's like what
could you use current that goes to the server for the feedback? Did you try that?
You know, I haven't wired something like that together myself, but when I first got back into robotics like 10 years ago, I was playing with Dynamixels, and that's how Dynamixels provide an approximate measure of the floor supply. They're just doing current measuring. That's as far as I've gotten. I used the API in the RS 46, 45 or whatever to read the current back out, but I haven't implemented that myself in any designs yet.
Well, I mean, I worked with the Lynx Motion Smart Servo. I don't know if it had the current capability, but it might have. I don't know. Look, it had a whole library that ran with the Arduino. Unfortunately, with the PIC chips I was working with, and the other chips I was working with, I didn't be able to do it. I had to write my own routine to serial drive it, but the damn thing worked when I got it all working. So it was pretty cool to see all the servos. Many servos I could stick in line serially. I can sit there and okay, move them around,
Oh, it's
cool.
It's so cool. And then there was the oh shoot, his name escapes me, but he did the rover design, and he found a kind of a cheap knockoff version of Dynamixel that uses serial communication but doesn't cost like $40 to $80 per servo.
Yeah.
I mean, when you're talking about more than 3 or 4 servos, that's the way to go. It is so nice.
Yeah, unfortunately, Lynx Motion servos are a little bit cheaper, but they're still like $30, $40 a piece.
Yeah.
And from my work, we got a hold of 3 of them, which is interesting. And the driver board that they have, the Adreno driver board for that, was interesting too. And like I say, it works fine with any Adreno thing, but when I tried to work at some of this 8266 and some of this other serial stuff that's supposedly compatible for it, that programs won't load or compile. So I ended up, like I say, I ended up writing my own servo control, basically bang it from scratch, which it worked for what we were doing with it. So
Tim, what's the bottom part of your shirt read?
What don't you understand?
Okay. It looks like a.
Don't you understand what it says? And the diagram is basically, this is a relaxation oscillator.
Right.
2 transistors. If you put LEDs or lights here, they'll blink like a semaphore thing for a train.
Oh.
Right here. But this is a basic relaxation oscillator.
Yep.
Of course, then the caption down here says, "Don't you understand?" with a question mark.
What part of flip-flop don't you understand?
That's what it says. I get some interesting comments from people about that.
I love that. That's great.
Some people recognize it, some people don't. You have to consider, I mean, I've been in electronics ever since I was like 5, 6, 7 years old, and I've seen it change a lot during my lifetime.
Wow, that's impressive. Yeah, that type of shirt is common in different fields. Like in physics, there'll be like this a relativity equation in like really
what it said
notation.
Just say the whole thing, Buzz. Up here it says, what part of this you don't understand, basically, is what it's saying.
Yeah, I figured that the circuit was in between the 2 dialogues. But
yeah, it's hard to. Can you see the rest of it now?
Yeah. Oh, that's great. That's great. I love it.
What don't you understand? It's fairly basic, Cool.
All right.
Well, you asked.
Yeah, no, that's cool. Yeah, they have shirts like that in different fields. Computer science.
Well, I mean, I got one that says Tesla's greater than Edison.
Oh, that's controversial.
He was greater than Edison. Edison was a hack.
You're gonna cause a storm here. That's like probably, I don't know. Maybe no one is on the other side. I have no idea.
Well, I mean, I'm not saying Edison was not smart. He was smart to a point, but a lot of the stuff he did, basically, other people in his company did it. He took some ideas from other people and he tweaked it his way enough to be able to bring a product to the marketplace. The big thing was he's bringing products to the marketplace. He wanted to do it
Yeah,
a
an
lot.
entrepreneur.
He was an entrepreneur and not an employee, which
Not-
Tesla was.
Well, a lot of the stuff, a lot of his people that work for him are the ones that actually made this thing work. And you're right, Tesla even worked for him for a while to the point where he couldn't take it. He couldn't take it anymore. He quit.
Yeah, we'll leave that to another time to discuss.
No, I like Thomas Edison when I was younger too, but when I found out that basically a lot of stuff that he did now, and I'm not saying he didn't do it, well, some things like the light bulb, some other people had the light bulb, but no one made it commercial, and the light bulb didn't last very long. So he kept tweaking filaments until he got filaments that actually would last long, and he went off from there. But again, he wasn't the one that invented the light bulb. Somebody else did, but he did make it practical. I'm not saying he didn't. Same thing. The phonograph was an original invention, but again, a lot of the other things that he did, we were basically his other engineers actually did it. He came up with the ideas, and that's about it.
Yeah, that happens a lot
He was a great business. I say he was a great businessman. Okay.
You could say, yeah.
That happens a lot in industry.
Yeah, Apple invents nothing; they just reinvent something better.
I mean,
if you,
yeah, Steve Jobs is in it almost.
Yeah. Have you ever? Yeah, he was always like that. I mean, I met him twice at 2 separate computer club meetings. Him and Wozniak, when they were still had the Apple I.
Wow.
So yeah, I talked to both of them. They're interesting. Wozniak was the hardware guy. Jobs came up with the ideas and what to do with it. What can we do with this thing?
Yeah, of course. Yeah,
and stuff like that. So yeah.
And Marculo, who you don't hear about, was the business guy.
Yes, he was a ex-IBM business person.
Oh, cool. Yeah, you don't hear about him.
Well, he helped them get going. Remember that you have to remember they started this thing in their garage.
Oh yeah, it was
the two of them.
Yeah.
And then it got to the point where this is a really weird part of the whole deal, but with Bill Gates. Bill Gates wrote the software for both of them, IBM and them.
Oh, right. They bought it from.
Yeah,
I read that Accidental Empires book. They talked about how.
Well, the thing is,
they bought an initial version of CPM or something.
Well, again, it was code. I mean, at one point in time, Bill Gates was really good at coding. I'll tell you what.
Oh yeah.
He was really good at it. He was great at it. He and his engineers came up with the operating system for IBM and for the Apple.
I heard they bought, actually, in Accidental Empires, it talks about how Bill Gates bought a version to begin with from another company.
Yes,
a Canadian company.
He spent a long time tweaking it to get it to
and
do
he
what
tweaked
he
it anyway.
Jim, it was Digital Research Corporation that actually originated CPM.
Yes, it was.
Right, yeah.
And then
he got a hold of a copy of it and tweaked it to the point where it was better than what they did and marketed his version of it.
I didn't. On the Apple side, though, Apple just. I didn't know he did anything for Apple. I thought maybe they just used that initial.
Well, the basic is what he.
Go ahead. Go ahead. Apple up to certain points they were writing their own software, but it got to the point where when they wanted to do something more with the graphic user interface and other things like that, they got to the point where it was easier to have Gates do it than do it themselves.
Oh, I'll have to look into that. I forgot about or didn't remember that.
Well, you have to remember they knew he knew everybody.
No, yeah, they were all.
Gates started in the garage too, coding.
St. James Infirmary.
Yes.
And just remember, guys, all of this started with the Altair.
Yes. Yes, I remember the Altair. Yes.
With switches on the front panel to enter all your code.
Yes, I remember. I had to do that for a company.
What about the Sol that was in Popular Electronics? The Sol, it was even before the Altair. Were you putting it together?
I mean, you have to consider. I went to Cal Poly Pomona. Each one of the professors who were working on different microprocessors out there.
Yeah,
was a 6502 Giro, 16805.
No, this was still in 8008.
Yeah, I mean, I was exposed to them all.
Yeah.
Intel 8008, Intel 004000.
In the
worked on stuff like that.
6809, the best micro.
Yes, I'm not saying that wasn't good. I mean, I still have in my possession, I have an 1802 ELF system that still works. I have an 1802 VIP system that still works. I got the little motherboard with the thing with the chip on, the little hand calculator thing that works. I have a Kim 1 that's still functional.
Yeah.
And I have part here and part there. I've got an Apple II Plus. It still works.
Yeah.
Yeah, I have one.
Fully loaded, speed synthesizer, the whole 9 yards. And I have an original IBM 1, just the main box now, but I had the original IBM 1, which I stuffed with 2 hard drives. I mean, I was really good at the hard drive thing for a long, things with IBM and all that stuff for a long time there when I was younger.
How about the Timex 1000?
Yeah, that was too tiny. That was too tiny, in my opinion.
What I kept was the HX40 from Epson. It was one of the first laptops.
I mean, I put my own 1802 together out of the Popular Electronics article and ran. Good
All right, hey
graphics,
guys,
the whole 9 yards, huh?
Gotta go.
I got a presentation to do. One last before we're running out of time here.
I'm sorry, I gone off on a tangent there.
That's cool. We might want to have some more time to talk about this very interesting historical stuff and vintage computing. You guys saw my I presented my PET Commodore PET 2000.
Oh yeah, I remember programming those too.
Yes, but anyway, the last thing or the thing I wanted to show now is in line. It's the same line that Thomas was talking about, is the speech recognition, and what Tim, actually you mentioned a few meetings ago that we were talking about doing local speech recognition is is definitely possible even back in the 80s. And so
yes, I worked on a couple of things there. I worked on let's see, what's a robot called Newton. And
yeah,
it's basically a 286 on wheels with a TI speech synthesizer and voice recognition card in there.
Yeah, so what I'm going to show is how I essentially switched over the Big Orange project to have an option to use the built-in speech recognition using, in this case, it's I'm on a Windows, so the back end is the SAPI, SAPI or WSR, the Windows Speech Recognition, WSR, which SAPI has been around, SAPI 5 has been around since Vista, Windows Vista. And now there are I'm doing this in Python. There are different libraries to do local speech, including there's this one that works under Linux and uses like the Carnegie Mellon backend. There's different backends available. So let me just play this video of my demonstration, and then I'll show you some code. Okay, so I'm going to demonstrate a couple of things here. I've added a local listener logic using SAPI Windows speech recognition to Big Orange, and also from there you can ask Google a question and it will send it directly to the assistant. I also added a mode, Google mode, which is similar to the previous version, except the hot word is interpreted by the local listener and nothing gets sent to Google until it says yes, and then whatever you say after that goes to Google. Okay, let's give this a try. Orange, resume listening. Orange, resume listening.
Okay, I'm listening.
Orange, status.
This is my current status. I'm at the office location. I'm with Jim. Battery is at 50%. And I'm feeling happy.
Orange, ask Google. Orange, ask Google. When was Matt Damon born?
Matt Damon was born on October 8, 1970.
Orange. Activate Google.
Okay. Google mode is active.
Orange. What's the weather like?
Yes.
What's the weather like?
Currently in Newport Beach at 63 degrees and cloudy. Friday, it'll be partly cloudy, with a high of 70 and a low of 59.
Testing 1, 2, 3, testing. This does not go to Google. Orange.
Yes.
When was George Washington born?
George Washington was born on February 22, 1732.
Orange.
Yes.
Where are you?
I'm at the office location.
Orange.
Yes.
Deactivate Google. Deactivate Google.
Okay. Google mode is not active.
So what I showed you there and is the ability, or what I've added is a local listener, and with this option to ask Google a question if you want as well. Since then, I've even changed it so that you, I kind of got rid of that Google mode. I don't even need it anymore. You can still ask Google a question by saying ask Google, and then it will kind of send it to Google. But in general, all of the standard commands to the robot are now local. And you should be able to see some text on the screen here now. And some of this is inherited from the LEAF project, which a lot of you are familiar with. And so to use the local SAPI Windows speech recognition system effectively, you need to give it a grammar of commands of language that you're expecting to hear. This helps the local speech system, which is not as sophisticated as current standard machine learned models, and which require a lot more power and memory than my small little robot, CPU, so that if you give it these hints, it will be much, much more reliable, and it's quite reliable with this grammar. So, and this may be review for people. This has been around for a long time. It was new to me, or it was nice to kind of go back to something like this and take Google out of take the cloud speech recognition, be able to turn it off. So with a rule, you can have, this is an XML format, and this gets to be not that different to AIML of ultimately. They can kind of cross each other or eventually meet. This technology allows you to put together grammars and even pick out words that people say in the middle, that sort of thing. So this, just to show you, I'm expecting one of the following things to be said first in this rule. So either orange or what's your name or stop. So these are things you can say to begin with that it's expecting. And then optionally, that's what O means, I'd expect one of these commands. So here's a bunch of commands. Now it gets more interesting when you have a sequence where there's some variability in the middle of what you're saying. So for instance, in this case, I'm going to say go, and this little plus means high confidence. So that means really kind of your algorithm should be really be above a certain level of confidence that you're saying go and not gone or something else, because this is a command to start moving. So this says go and then one of forward, backward, right, left. And then optionally, you can say at an angle, degrees. And this is what's interesting, a reference. So you can use a reference that points to another rule. And I can show you the angle rule is down here. And this says optionally say negative or minus, and then I'm giving some common angles. I'm not expecting to use every possible angle. And now even without any of these, the SAPI system may be able to interpret what you say, like 47 degrees, but it'll have a less reliability. And these will be almost like very, very high reliability to interpret. And so to finish what I was showing you, go this particular angle, and then I use the distance ref, and then of course one of the type of units. And distance is made of is also a combination of digit, which is 0. The digit is right here, 0 up to 9, and then I added 10 in, and then just for kicks, and then point is optional, and then another digit and a second digit. I'm not sure, I don't know how to do recursive yet, or if there's a way, but at least you can say 1.25 meters, which is probably good enough. 2 decimal places. And so this gets loaded in by a very simple, or this XML file gets loaded at when you want to invoke a rule or set it up. You can also change the rule that's active. In this one, robot commands is the top level. And if you could have multiple top level rules that you can activate and deactivate. Anyway, we're kind of running out of time for the official meeting. So I'll wrap up and ask and see if anybody has any questions. Rather, I won't bother doing a live demo, but it is quite reliable for the when you ask. And the code is quite short, or it's using this library called Win Speech. It's a very readily available on PyPy in Python. So you can download this, or you can install this Win Speech. I've modified it. I forked it and forked the GitHub, and I added the ability to load that XML file, for instance. But this is easily available. Yeah, sure. My YouTube is my YouTube channel is just under Jim D'Annunzio. I'll post it there. But any questions?
Yeah, Jim, can you hear me? This is Bob Barbosa. I got one question for you.
Yeah, hi, Bob.
Yeah, you mentioned AIML.
Yes, that's Thomas has been giving talks on that.
Okay.
And that's the it's a markup language for chatbots, and he's been using it extensively to create a personality and an advanced chatbot with his Simeon project. So it can attempt to be as convincing as possible as a conversational companion.
Is that what Thomas used to get that female voice?
Yeah, well, the voice synthesis is using a synthesizer, but that's slightly different. But the AIML is is essentially the knowledge and the interactions. The scripted, some of it's scripted and programmed, and some of it is, well, it's basically, it's all scripted, but it's a language that you can put in queries and responses so that if someone asks this question, the robot knows this is the answer. And you can put wildcards in there too and capture words. So if the person says, I like blah, you could capture whatever blah is, and then you could use that in another sentence, like, oh, I like blah too, or, you know. Anyway, that's AIML, is this whole chatbot markup language. Is that?
Yeah. Bob, if I could just interject just a quick thing here. AIML is actually the natural language processing aspect of a speech recognition, processing, and speech output type system. It's the middle piece where it takes the queries in or the comments in and then maps them to responses and then responds through the speech synthesizer. That's typically what it does.
Okay, then now that I know that, I'm going to ask this one last question. I'm working with 3 now robots, and they're having a conversation with each other, and I want them to be able to have a conversation with Siri and Alexa. Would it be worth my while to study AIML?
Well, you're trying to have them talk to each other. Yeah, I mean, the thing is with those are, you're trying to have, well, the Now robot, right? You're talking about, and you're talking about Alexa. Those are all systems that have their own, I assume, have their own speech kind of integrated. Well, certainly I know about Alexa, and has skill. You can create your own Alexa skill. You can, there's you know, to make Alexa talk, it's a similar type system, but it's totally different than AML.
And one of our club members has got into Alexa to the point where you actually could change the voice to make it sound anybody you like, male or female.
Well, that's the synthesis part, right? But
yeah.
We're kind of talking about the interpretation part. The intelligence is all in the scripting, right?
Yes.
And so within Now, I don't know how Now works, but you might ask. Walter probably has some ideas.
So Bob, Now has a limited numbers of questions and answers pre-programmed. So anything different than what it already has, it won't understand it, and it won't know what to do with it.
So Walter, you cannot program Now then with voice recognition or voice synthesis?
Yeah, but you have to pre-program the questions and answers.
Yeah, but the thing is, I mean, is Now capable, independent of the scripted stuff that's built in to Now, is it possible to get the speech recognition output to an algorithm that you embed in your programming or anything like that, and to then take whatever you've done and then now output it to the speech synthesis aspect of Now?
Yeah, you can do those things. Yeah.
Well,
okay.
You know, I have 2 tools. I have Python and I have C++. And I'm able to work with my dialogue, and I have an opportunity to integrate the C++ while I'm working with that dialogue. So I've been able to get the 3 robots to talk. Now they have to ask questions, of course, to Siri and to Alexa. So I'm working on a little scenario. I'm doing a thing where I'm pretending I'm an astronaut going to Mars, and these 3 robots are helping me with the science experiments. So of course I have all the science experiments, and I'm just trying to get a nice dialogue going, just as if we were making a movie.
So you can script all that up front though, right?
Yes.
Well, yeah, you could use AML for that.
Okay, that's what I needed to know. All right.
Yeah, but AML may not work on the. I mean, AML works on like a CPU on a computer. You have to have a program running. You know, if you want like if you want to have one of those the Now robot talk to something, you have to use whatever is the Now syntax, whatever they're using for their. It's similar. It would be similar to AML. AML is a specific one that runs under Windows and Linux, and you know, it's your own. You have to have a program running it. But if you're working within one of these systems, you're going to have to use that. You know, like now you can't just throw in any code. I assume you have to use its APIs.
Yeah, I'm able to use, of course, Python to manipulate it. Like I used to have a problem where all the sentences would run together and I needed to pause. I needed to, you know, have a sentence where you would use a comma and you could lengthen the delay in the sentence. And, you know, if you just use a comma, it'll run right over that comma just as if it was a word. It doesn't pause like a real human being.
Oh, it
doesn't.
It
So
should.
what I needed to do is I needed to use the comma like a human being uses a comma and be lucky enough to lengthen the delay.
And no, most of them do. Most speech synthesizers will honor the comma. So I'm surprised.
Yeah, so I'm going to go back and revisit that next week, but all of this has been really helpful. My last question is, when will we resume in-person meetings again?
Oh, we covered that at the beginning, actually. Alan,
okay.
Just you can watch the video. But, Alan gave a longer response, but
the short answer is sorry. Go ahead, Jim.
Yeah, the short answer is we'll know more. It could be a few months, but we don't know yet. Is the short answer.
Okay.
Yeah, even though they just recently said if you're vaccinated, you don't have to wear a mask anymore. Individual states are still fighting that sort of thing.
Yeah, it's up to the university, and we're as an unofficial club that just uses campus facility. We're in the third category and the first category is the sports are already starting to resume, and the second category they're talking about, which is official. So official clubs that are university clubs. So we're third, and it could be, you know, it could certainly happen in the next few months. So we're gonna get an update every month.
Yeah.
Okay.
Jim, what's this thing you're saying about the latte panda here? I didn't quite get your comment here.
I was just responding. I was trying to listen and type. It gets kind of difficult. My mind can only do one thing, but Sinan was asking how what this model is. That's the CMU model I was trying to remember is called Sphinx, and this has been a popular back end for speech recognition that's completely free and available and works under Linux as well as Windows and Apple, of course. Well, Apple's Linux too, but now the SAPI is a Windows only model, which is quite old and it's not a modern machine language model. So it may not even be as good as CMU's. I'm not sure, but how up to date CMU Sphinx is. There is another. If you don't have Windows, you can use other. You can use CMU Sphinx, and in fact, there's other Python interfaces to do that, including this. I forget the name of it now. There's another front end. So usually you'll have a front end in Python and then a back end, and to do the actual. That's kind of in the operating system or the hardware, and the front end is a system that handles the high level commands, the grammars, all that sort of thing, the rules like I just showed you, and that's what this the SAPI actually has both functionality. It has a front end and the back end, but it can be used as just a back end. So anyway, I'm just using this Win Speech, which is a simple Python front end that uses the COM. If anybody's familiar with old Windows COM interfaces, COM, that's what it's using. And the COM interface is to this built-in operating system speech recognizer. But there are, yeah, again, with Linux, a lot of people are not on Windows, and in fact, I may move my code over to this independent high system that can handle multiple backends. So you can tell it use Windows SAPI or use CMU Sphinx or something else. But CMU is also local, and that's sort of the advantage here. And I'll get that name in a minute. I just forgot. Does that answer? Anyway, that's all I had. We're kind of over time. Anybody have any other questions?
Oh, I had something quick, but we can
go ahead,
leave
Walter.
it
Go ahead,
later.
Yeah, we'll just end the official meeting now, and so this is just a formality, really. But for anybody thank you for attending, and we'll stop the recording. Thank you for